Today we are going to study Science and Technology Part 1st. Chapter 1 Gravitation. In the last videos we had already studied what is gravitation, what are the effects of gravitational force, and about Newton's universal law of gravitation, which was derived with the help of Kepler's laws of planetary motion. In this video, we are going to learn about the effects of gravitational force on the objects or body. Free fall. We know that the force of gravity due to Earth acts on each and every object. When we are holding a stone in our hand, this stone is also experiencing this force, but it is balanced by a force that we are applying on it in opposite direction. As a result, the stone remains at rest. Once we release the stone from our hand, the only force that acts on it is the gravitational force of the earth, and the stone falls down due to its influence. Whenever an object moves under the influence of force of gravity alone, it is said to be freely falling. Thus, the released stone is in free fall. In free fall, the initial velocity of the object is 0 and goes on increasing due to the acceleration due to gravity of the earth. The initial velocity is 0 as it is in rest position. During free fall, the frictional force due to air opposes the motion of the object, and buoyant force also acts on the object. Thus, free fall is possible only in vacuum, as in vacuum there is no air to oppose the motion due to frictional force, or any other force cannot be applied in the vacuum. For a freely falling object, the velocity on reaching the earth and the time taken for it can be calculated using Newton's equation of motion. We know there are three equations given by Newton for motion. First, V is equal to U plus AT. Second, S is equal to UT plus half AT square. Third, V square is equal to U square plus 2AS. These are 3 Newton's equation of motion. For free fall, initial velocity U is equal to 0 and the acceleration that is acting on the body is equal to the acceleration due to gravity, that is g. Thus, A is equal to small g. Then we write the equation as V is equal to gt, S is equal to half gt square, and V square is equal to 2gs. We obtain this equation by substituting U as 0 and A as small g in Newton's equation of motion. Now, for calculating the motion on an object thrown upwards, the acceleration is negative. That is, it is in opposite direction of gravitational force. Therefore, acceleration is taken as minus g. The magnitude of g is the same, but the velocity of the object decreases because of the negative acceleration. The moon and the artificial satellites are moving only under the influence of gravitational field of the earth. Thus, they are all in free fall. Gravitational potential energy. The energy stored in an object because of its position or state is called potential energy. That is, the potential energy is the energy in the body when it is in the state of rest. The energy is relative and increases as we go to greater heights from the surface of the earth. We had assumed that the potential energy of an object of mass m at a height h from the ground is mgh. On the ground, it is 0, as height on the ground is 0. Thus, substituting in the formula mgh, we get potential energy equal to 0 when the object is on the ground. Now, when h is small compared to the radius r of the earth, we assume g to be constant and can use the above formula, that is mgh. But for large values of h, that is when the values of h compared to radius of earth r are significantly large, then the value of g decreases with increase in h. For an object at infinite distance from the earth, the value of g is 0 and Earth's gravitational force does not act on the object. So it is more appropriate to assume the value of potential energy to be 0 there. Thus, for smaller distances, that is smaller heights, the potential energy is less than 0, that is it is negative. When an object is at height h from the surface of the earth, its potential energy is minus capital G into capital M into small m upon r square. Here, capital M and capital R are Earth's mass and radius respectively. Thus, we conclude that the potential energy, or rather gravitational potential energy, is always negative, given by formula minus gmm upon r square. Escape velocity. We have seen that when a ball is thrown upwards, its velocity decreases because of the gravitation of the earth. The velocity becomes 0 after reaching a certain height, and after that the ball starts falling down. Its maximum height depends on its initial velocity. So, according to Newton's third equation of motion, that is v square equal to u square plus 2as. V is the final velocity of the ball, which is 0, and A is minus g, as it is acting opposite to the direction of gravitational force. Therefore, substituting the values, we get 0 is equal to u square plus 2 into minus g into s, and let s be the maximum height of the ball. Thus, higher the initial velocity u, the larger is the height reached by the ball. The reason for this is that the higher the initial velocity, the ball will oppose the gravity of the earth more, and larger will be height due to it when it can reach. We have seen above the value of g keeps decreasing as we go higher above the surface of the earth. Thus, the force pulling the ball downward decreases as the ball goes up. If we keep increasing the initial velocity of the ball, it will reach larger and larger heights, and above a particular value of initial velocity of the ball is able to overcome the downward pull by the earth and can escape the earth forever and will not fall back on the earth. This velocity is called as escape velocity. Thus, escape velocity is the velocity with which an object or body can escape the Earth's gravitational field. We can determine the value of escape velocity by using the law of conservation of energy as follows. Consider an object going vertically upward from the surface of the earth, having an initial velocity equal to the escape velocity. Escape the gravitational force of the earth. The force of gravity being inversely proportional to the square of the distance becomes 0 only at infinite distance from the earth. This means that for an object to be free from the gravity of the earth, it has to reach infinite distance from the earth. That is, the object will come to rest at infinite distance and will stay there and not fall back on the earth. For an object of mass m on the surface of the earth, kinetic energy will be equal to half mv square, potential energy equal to minus gmm upon r, total energy equal to kinetic energy plus potential energy, which is equal to half mv square minus gmm upon r. Here v is the escape velocity indicated by v escape. At infinite distance from the earth, the kinetic energy will become 0. Potential energy will be equal to minus gmm upon infinite. Thus, the potential energy will also become 0. Total energy addition of kinetic and potential energy will also be 0. From the principle of conservation of energy, E1 equal to E2. Therefore, equating both the equations of total energy on the surface of Earth and at infinite distance from the Earth, we get 1 by 2 mv square minus gmm upon r equal to 0. Therefore, V escape square equal to 2 gm upon r. Thus, escape velocity equal to square root of 2 gm upon r. But we know gm upon r square equal to small g. Thus, multiplying and dividing 2 gm upon r by r, we get escape velocity equal to root 2 into small g into capital R. We already know the values of small g and capital R are 9.8 and 6.4 into 10 raised to 6 respectively. Thus, substituting these values, we get escape velocity equal to 11.2 km per second. The spacecrafts which are sent to the moon or other planets have to have their initial velocity larger than the escape velocity so that they can overcome Earth's gravitational attraction and can travel the objects out of the Earth's gravitational field. Thus, when objects travel with the velocity greater than the escape velocity, they can overcome the Earth's gravitational force and break through it into the space. This is the end of our chapter. Do solve the questions given in your textbook. If you have any doubt regarding this chapter, do ask in the comment section below. Do subscribe my channel and click the bell icon for notification. Do like and share the video. Thank you.